many Go technicians does it take to write a chatbot? Just Mariah. But thanks for coming. Hopefully looks like we've got a few more sandwiches left, so feel free to grab those. If you were here for the Go group for October. It's October 7th. This is the latest in the month it can possibly be. First Tuesday of every month. It's not important. It's just fun for me to realize that I'm like a lot earlier in the month. We're really into it now. I have this warning. The microphone is actually recording up here, so it's not as much of a thing. But these ones will pick up other stuff, and they'll get on, if not on the recording, to people on the call. So the warning is still there for these microphones above your head, these things with little green dots. They will pick up your whispers, and everyone on the call will hear all of your private thoughts.
That you say out loud. Yeah,
that you say out loud. So just a heads up, you still whisper, just whisper nice things to other people on the phone call. If you want to speak here, there are multiple ways to do it. To be very, very frank with you, nobody submits with this paper call. They just come talk to me and say, hey, I want to talk. Or they can go to Slack. ForgeUtah.tech, how do you get the Slack invite? If you're not on there, go there, join our Slack, go to the Go channel, say, hey, I want to speak, and someone will point you at the right people. That's pretty much the pipeline. Is either in person or Slack. We do get emails if you want to submit here. It's just not how most people do it.
This slide is irrelevant to 2024.
Yeah, fair enough. I'm not even going to update it. I'm just going to leave it like that.
Send a screenshot.
So we are continuing. A talk today is about the standard lib. There is still so much standard lib to cover. There is always more standard lib. Even though they aren't really adding to it that quickly, we are adding to it, but there's always more. There's so much that we have to cover. I think next year we have FUMT being covered, but like log still isn't covered. Slog package, which is related, isn't covered. Like there's.
I have somebody for JSON.
Okay, so we got JSON, so that's good. And there's a JSON 2 coming, I think, which is fixing a lot of the like
it's in release candidate?
Finicky stuff about the current JSON package. So there is stuff in the standard lib. There's more coming, and we have a lot of even just core packages still aren't hit yet. So if you want to speak here, welcome. We've had a lot of first-time speakers. We had a great time. It's a very welcoming group. Very chill. People will correct you, but very nicely and in a teaching way. It's a great place to come speak. Very, very honestly. Like I think it's one of the best places to kind of like build up your public speaking, technical speaking chops. And if you want to speak on any of these standard lib packages, go to the Go to Slack, go to the Go channel, and there is a called Canvas, which is like a wiki on a Slack channel, where we've kind of broken down some ideas of some good groupings of packages or striking them out as we go through them. And if you don't know, if you just want to talk and you have no idea, come talk to me, come talk to, Brandon is not in here right now. Go to the channel. We will, if you want to speak, we will get you to speak here. That's my promise to you. I've been saying this for a long time. I am not rejecting any speakers. I might work with you on your talk if you're new, or we might like ask to see it ahead of time and kind of iterate on it, but I want everybody that wants to speak will get a chance here because I want to give a lot of people that platform. There is a jobs channel. It's actually pretty neat. If you're in Slack, we always put in the jobs channel because it's kind of got a Slack workflow now. It's automated. It's pretty well organized. It's a list of like, there are still people hiring for things. Looking to hire or get hired. There you go. Wearing the shirt. It's a different year. Same idea. This building, this whole floor, is it the whole thing, right? Yeah. This is like this giant room twice the size over there. Is Go West, October 24th. Are there any tickets left, Mariah?
There are exactly 65 tickets left.
65 tickets left. It's really, really affordable. If you really can't come,
if you can't come, we have volunteer opportunity. If you can't afford it, if you attend the Catalyst Community Meetup, you can get a free ticket because Todd has some, or you can volunteer and you will also get a free ticket. Yeah. So there are opportunities if you can't afford it. The tickets are $100, and it's the best Go conference in the world. So.
Yep. So really a lot of fun. It's really low. A lot of local stuff. We do have people that come in.
Carson's speaking.
I am speaking. I'll be talking about the AST package. So
I'm speaking.
We'll learn about AST. Mariah's speaking. It's a really, really fun meeting. Like for $100 or cross volunteering, like it's a fantastic conference, and it's right here. So if you can make it here for this meetup, you can come in on Friday, which is the 24th.
There's a guy coming from Japan. There's a guy coming from Japan.
Yeah, there's a few
People coming from Japan.
from far away. I don't know why, but I'm glad that they're here. So there's an after party with drinks included in the ticket price. It's a lot of fun. So come do that and get your, what are we giving away? We give away stubbies, like, right?
No, we're selling plushies. So we're selling plushies as to raise funds for next year's conference. We're giving away conference tickets to the 2026 conference, and we are potentially looking at getting Legos and keyboards and meta glasses and other. We raffle every year. We've got about
Raffles got my
we've
amazing.
got about $1,000 budget that we just buy random things to raffle. So.
Yeah, so come to that. If you're not coming, I highly recommend that. It's a really, really fun conference. I'll stop rambling on. I'm going to pass it over to Michael, who's going to talk to us about the context package. Speaking of fundamental Go standard lib stuff. So, yeah, thank you.
Yeah, Carson's pretty serious about letting anybody. I'm walking testament to that. Okay, I've come prepared though. This is my first technical talk ever, so I'm really excited to take it out. Yeah! I was working in a, start off with, so I work at Stacks Payments. Just a basic payments processor, about 300 people. I'm a senior software engineer for them.
Yay, Michael, you made it.
What?
I said, yay, Michael, you made it.
Yeah, I made it. Let's see, what else? So I've been doing Go since 2015. I was a pretty new engineer at the time. So I have 4 sons, live in Saratoga Springs. I'm passionate about learning, personal growth, people. And yeah, this is my first technical talk, so we'll see how this goes. I asked Carson if I could speak on the context package. He said it hadn't been covered in a while, and I had been working on a migration with using this package to implement tracing. I basically spent 2 months getting this. It was kind of my first project when I started my new role. Was doing this migration, so I thought, oh, I've been using it and comfortable with it. Why not speak about it? All right, so what is the context package for exactly? Well, I mean, depends on who you ask and what you're doing with it, but these are, asking Gemini, these are the things that it basically told me, was that manages concurrency, manages request life cycles, and essential metadata going across Go routines. And that's kind of what I thought of when I first saw it. I was like, this is a lot. But this package is actually pretty useful and actually doesn't have a lot of functions, so you could potentially, functions and properties to it, so you could potentially memorize the whole thing if you wanted to today. So just kind of jumping in with the request lifecycle control aspect of this, allows a parent operation to safely signal and terminate child Go routines early. So basically what context is used for is when we have concurrency, we want to be able to spin up a Go routine or a child process and have it do some work. And that we have a parent process, and the parent process needs to be able to control the child process still while that child process is running. And so essentially what we can do is we can signal to it using channels under the hood, but using this context package. We don't have to get into channels and write our own custom stuff. We can simply just call context cancel. And then that will tell the child process, if it's listening, it'll tell the child process to be done and to wrap up. So that kind of relationship is what this package is, one of the main focuses of the overall package. I think I may have skipped over it earlier, just want to check my slides. Yeah, I was introduced in 2016 in version 1.7. And if you're like me, when I was first writing Go, we just passed the logger down in every single function in our entire repo. We didn't use the context to pass metadata. I wouldn't recommend it. So we do, we are pretty serious about being able to being able to pass those parameters down and have context hold those things for us, that we can use, but we definitely want to pass context as first parameter possible. Let's see. So as far as like timeouts and deadlines, the context allows us to enforce strict time limits on blocking operations like making an HTTP call to another service or a gRPC call to another service. To prevent resource hogging and like infinite waits. It could also be an internal wait you're waiting on. It could also be a database call that you're waiting on. But we want to be able to time those things out and say, hey, you're done. You don't get any more than 2 seconds or 2 minutes or whatever that process needs to be. So this is just me. This is just a pretty rough diagram, kind of showing what I was explaining earlier. We have a parent process. The parent process makes a call. It's waiting. Perhaps it's waiting on a call to another service database, like I just mentioned. The child process is going to do its work. It's going to try and get things done, and then if it runs into like it's taking too long or something like that, we can tell the child process, hey, you're done. Even if that's another service, we can say, hey, you're done. I actually misspoke on that, but the idea is that you can pass the context. We'll get into this a bit more, but you can actually pass the context along, and the service will tell itself. So timeouts are used a lot. Here's just one example. I've tried to divide the code into like parent code and child code so you can kind of see. But this is just a basic context with timeout, and we're actually just do that. That'd be nice. And so essentially this child code, this context.done is a channel that's waiting to see if the parent says, hey, finish up, wrap up. So that's that. When I first started getting into this, I was kind of confused as to like why you want a timeout. So I just wanted to touch on that briefly. I work at a payments company, so when you take your credit card and you put it into a payment terminal, like you're going to buy a sandwich or something, you really don't want to be waiting there very long because you're literally part of the reason that there's a queue of people behind you. And so we want that to be within under a second. That is over a second, I want an engineer to get alerted that's going on. And by enforcing a timeout, I can actually set metrics around that and be alerted and say, hey, your requests are just timing out, they're not working anymore. So I can enforce like a hard SLA for something like that if I really needed to. This is a similar situation with like real-time ad bidding. If you're gonna hit an ad server and then going to they have requirements, this must be done in 80 milliseconds. If it's not, you don't get to bid, your company gets no money, sort of thing. That's a more, like, I'm trying to think of diverse examples. And then obviously you can use it for metrics for teams, if you're doing like streaming or something like that. Then you can be notified immediately. These also kind of help with like, if you have a system that's very slow and non-responsive, like your database calls are taking too long, you're holding up other database calls in other parts of the system. You don't want your system to be tied down, to be kind of caught in like everything going down at once because some requests are failing. And we work with database connection pools a lot, so we want to be able to return those database connection pools back to the pool and give resources back. So it's really, really, really important when you're dealing with this kind of stuff that you want to be able to say, hey, this is taking too long, we're done. Somebody else gets that database. Somebody else gets that database connection now. So it kind of keeps your offending code will fail, but it kind of keeps the rest of the system pretty safe from hogging resources and things just going rogue or leaking overseas and things like that. So it is a really big deal. It's not complicated, but it does impact the system quite a bit in that way. Did I miss anything? Yeah, so I kind of hit on those things. Standardized data passing. This is actually not something I've done a ton of. No, I'm not passing my logger as a parameter as we're using it. But this is something that you want to be, we can pass like tracing information or telemetry information in a context, in context as you're going from in your call chain, basically. And so that's the metadata that's being referred to. So tracing IDs, span IDs is what I've been using it for lately. There's blogger stuff in there, the kind of the more, this older system I'm working on. But I love that user ID is still in here. I wonder if I put that in as a joke, but probably wouldn't want to put a user ID in your context. So anyway, and so yeah, so usually the convention here is that we want to pass the context as the first parameter. And so there's other languages that like kind of chose to do under the hood. I kind of like the the obviousness that's like this has a context in it. This is how it's used. This is what you can expect for your concurrency management. I think that there to be discoverable. So here's an example of how you might pass a value. This is very just, I have a demo at the end that's a bit more in depth, but this is just, again, dividing it from parent and child, what the parent would need to do and what the child would need to do, parent function and child function or routines. So you can see we have this context with value, and a key that we can go ahead and retrieve it from, and then I can check to see in the child code. So we would set that in the parent, right? We would set a value with a key in the parent, and then we would call a go routine and pass the context with that value in it. And then when in the child, if they want to check to see if the value is there, we can check. We have this OK parameter we can use. A lot of us have done Go, probably recognize this, but basically we can check and say, does this key exist? And if it does, I can do something with it. And if it doesn't, then I can also, move on or from there or whatever it is I decide I want to do with that value.
Quick question.
Yes.
On that slide. Can you speak to why you might choose to use that pattern rather than just passing an explicit string in to the child start function?
So I personally would just pass something in. I would never do like a user ID or something like this. I think that that the thought here was that they support this for as metadata, maybe like a tracing object or something like that. But it really isn't quite as related to the functionality of the child. I would if someone put this in just randomly in a PR, I would be like, hey, what's this doing here? I'm not quite sure what we're doing. But I would fully expect the person to, I fully expect us to have more OTel kind of stuff in there, or tracing and that sort of thing. And that's kind of what this is careful what you wish for, because you don't want things there that shouldn't be there.
Yeah.
So, yeah, do not be putting things that are related to the functionality of the function in there, like parameters. It's more so for tracing information or a logger that you might use or something like that. And even then, you try and keep it pretty lean. That's one of the reasons why, to your point, is I haven't put tons of stuff in there because I want things to be pretty discoverable. And yes, this is not, it's there's a term that's been coined calling it Santa's bag. You don't want to be using Santa's bag for stuff like that.
I've seen some libraries that will use the context to store parameters and stuff for HTTP calls. Do you have opinions on that?
I have not come across that directly. I'm interested in feedback though, yeah. Sorry.
We're gonna go first.
Well, I was wondering if we were gonna get the same thing. One of the uses for key value would be if you're doing a query parameter search, put gRPC, like you wanted to have an HTTP compatible. Essentially, the way if you have ever used, what was Jason Newman's gRPC Go package for Postnet? I don't even remember. But essentially, the way that he did it was you could put query parameters in the context. So so if anything after the % sign not the % sign, the question mark would, in an HTTP call, if you were going to make that compatible with gRPC, those would get loaded into the context. So it's I don't know. I feel like I would say using it as a key value store is not necessarily a best practice. I think it's just something that we have kept around for compatibility, especially when you notice that it shipped in 2016 and you're like, when does Kubernetes released? We were dealing with a different layer of networking and service mesh wasn't a thing, and we weren't, the way we shared information was just not the same. But yeah, it's more of just I think if it's mostly for network information or metadata type information, but again, that's not how I would do it in whatever this current version of modern software is. Sorry.
No, that's great. Yeah, and I can elaborate further. So, okay, right. You've got a function calling another function, and the debrief function needs to use the user ID in logs. It needs to use well, we'll keep user ID, even though it's not necessarily like, it's not using the user ID for business information necessarily. That gets a little tricky. It needs data for like a request ID, right? You make a request into a server. Something at the very tip of that, it's a middleware, it's going to generate a random ID for this is the request ID. Now I need it to follow down everything that happens as a result of handling this request. It needs to be able to attach this request ID, if it can find it, to the logs, right? If it can't find it, then you just put a 0 value or you leave it or whatever, but you want to attach that. If you don't have context, then what you have to have is that every layer, every function, your handler functions for like your HTTP server, have to have a place now to pass the request ID, right? Like, and if you're using somebody else's MUX, if you're using someone else's third-party thing, if any step in that chain doesn't have a place where you can say, and here's the request ID in case you need to attach it to logs, like, you can't use that library, it falls over. So one of the main values of context is the interop. Yes, you don't put everything in there, but there are certain places, typically when you cross package and ownership boundaries of code, where I literally can't change somebody else's code to start taking my request ID as part of every function. So I'm going to jam it in the context. They've kept this very vague blob of context that they pass down their code base. And then when it comes back out into the code that I've called that's kind of hooked into their library, I can get it back out of the context. That's like one of the main use cases, is everything's plumbed through with Santa's bag. Everything's like, I don't know, here's Santa's bag. I use it for signaling, and I'm going to pass it down to the next thing in case something that called me put something in there, and then I call something else that isn't my code. It's really about the interop between all the layers is where you get like tons of value. Like, it is more vague, but it is everything is
Like the
plumbed
Tracy
that
example
bag
he was
into their code base, so you can kind of put whatever things you need in there and get them out where you need them.
And I think it really comes down to, like, I don't like the word meta very much, but it's kind of like, is this related to the function you're passing directly? It should probably be a very clear parameter. Is it something that is related to the ecosystem that you're working in? It might go in context.
Yeah.
You know, I want to be pretty soft on that, but like that's kind of the, you know, even when she was talking about like Jason Newman's gRPC stuff, like that's kind of more networking stuff. My function that's going to go hit the database and pull something doesn't need to know about that. It just needs to go into, you know, that would be a Santa's bag example.
Yeah.
I just wanted to say, even if you do own all the code in your whole stack,
It's onerous to change it.
yeah, especially, you know, oh, hey, we're gonna add tracking to this, you know, this set of calls. Oh, we're gonna tweak this here and there, and suddenly, without using context, you have this spaghettification of all of your signatures that just gets really ugly very quickly if you're trying to track a bunch of different things across a medium to large organization.
I had to do that.
You've tried to do it with a map, right? Say you're like, I don't like context, I'm just gonna pass a map of string any. Like, there's all these like immutability problems with the map, is because anything you pass that map can just change the values for all of the other things. There's access, concurrent access problems, like.
My very first Go repo was written in 2015 before this package existed, and we had a request object we had to pass down in lieu of that, and it was awful. It was terrible. Like, sure, we don't want to put whatever in Santa's bag, but like if it goes in there, it belongs in there. Do you have a question?
So, well, I had a comment, but did you already talk about typed keys for context?
No, I didn't hit on that.
Okay, because
Why don't you tell us?
one of the nice things with context in HTTP requests, because you can have typed keys, even though putting something as a context value removes its type, you can type the key, and then if ever you change the type of a thing that you're using, you change the type of the key as well, and then that will force you to make sure that you hit every single spot.
Right, that makes sense.
Well, we'll go over. That's a really, really important part of context. I'm sure in your demo we can probably tweak the code, so. I don't want to derail you too much.
Well, I don't really touch on that in the code. I just briefly go past keys because most of the time I actually focus on something else in the demo. So if you want to make a comment, go ahead.
No, that's, I think we'll maybe elucidate on your code.
Cool.
So.
That sounds great. I love all the input too. I'm not up here to just listen to myself talk. So. Here's a few things that rely on context. When I first started looking into this package, I realized I have not written a bunch of select statements that listen for processes, yet I've written a lot of code that handles processes. And I was kind of like, wait, have I been doing this wrong the entire time? No, the answer is that this context.done is actually in a lot of the packages and libraries that I use. the net HTTP package, database SQL package, and so on as I've listed here. And other kids you may know, it's just to remind me to make that comment. But basically, like, a lot of the children processes that we might be dealing with probably have that select statement built into them and are listening for the context on that side. So that means that all, you know, not all the time, but there's probably more often than not, you're responsible for what context you put into your libraries, but maybe not actually doing the context.done part of the year. Yeah, so.
I will say that rely is doing a lot of work in this, a lot of work in that sentence. It needs a context, but it could be completely empty and not actually care. I think that's actually important for the actual use case that is in the Go library. Nothing is coupled to the context. There's nothing inside the context that any of the code in the standard library is saying, I absolutely need this, we're all coupled to the same thing. That coupling doesn't exist. You should follow that pattern and not couple your code to the context. Everything is like additional functionality based on the context, right?
Well, a lot of these are, almost all of those use cases, when you pass context, you're passing it for installation.
Yeah.
That's what it's for. It's like,
I
you
know.
never call and you need it to like only take a second, come out, run the process, you process early.
It's
That's,
signaling across the tree.
yeah, they almost never use the value stuff internally.
Yeah.
Yeah. All right, these are just some examples. So we basically have the with timeout, with deadline, and with cancel. I can put context to do in here. Here's some random examples of what the relationship might be. But they all rely on the context.done to say, hey, I'm done, let's finish up. So I'm trying to think of anything else that needs to really be touched on here, but it's pretty self-explanatory. I guess we can talk about the difference between timeout, deadline, and cancel. So timeout is, as you can see, kind of I have like 3 seconds in there. That's how long it's going to take. Absolutely, the with deadline is basically how long that deadline is. Actually, I don't know if that parameter goes in there.
That's the wrong, yeah, not to,
For that.
that should be a time.time.
Okay, that makes sense. I'm
So
just
that would
catching
be
that.
like a very specific, at this moment in time, that's when you should die.
Yeah, okay. That makes sense. So so what we're saying is that this, this blue line, context with deadline, doesn't actually take the 3 seconds. It takes a time like he said.
So like, instead of saying, I want it only to take max 5 seconds, say, run until this time tomorrow.
Yeah.
Like, if you want to do like 24 hours, or like you want to make sure everything stops before midnight or whatever, like that's what that would be for. Very rare use case, but.
Yeah, it is for longer, it is a way to like time box like longer processes and stuff. I also was thinking about in the, like more so in the context, no pun intended, of something like maybe that context came from something like another service or something like that, where it's like we have this deadline that we're all working on and it shrinks as it gets passed from the service, which probably isn't quite as relevant. And then we have the cancel, which is just, hey, when this, if we have an error or if we have an issue, we're just going to call cancel and be done. So it's more like manual control. So you just basically have that function that you can call at any time just to terminate it, like just by declaring cancel done, right? So that's kind of what that bottom one is. But yeah, they all respond to it, this context.done function. All right, so in Go 120, they introduced cause. And so cause is basically an error type. And that it just allows you to be able to call the error or say, hey, why did this die? And so I just have a quick example there. Context.with cancel cause, and then a way to get it out. So we can create it. You do have to actually create the context with cause up front. So you have to be like, I am going to handle this, this issue with cause. Take it into account. And then the child can say, okay, context.cause, if it does get signaled, this is kind of confusing, but if it does get signaled to say you're done, then the child process can say, oh, okay, well, why am I done? Why are you signaling? And then it can run from there and make choices based on what that is. So it's just more granular control, yeah.
There's some fun flavor to this. So I don't know if anyone who's been doing Go for a while, seen the error, done it for even 5 minutes, like context deadline exceeded, right? Error, context deadline exceeded. We've all probably seen that like a million times. And when you get that as the client, you kind of like, A, it's really vague. It's very accurate, but kind of vague if you don't know Go terms. And B, if there are layers. So can you step back?
Like,
You slide, sorry.
not me.
Sorry. Yeah, I can't see the behind you.
Anyway.
So pretend there's multiples of that top pink one, right? It comes into the HTTP server. The server says, this request is going to time out in 60 seconds. And then you come down into some fork of the code, and half the time you send it down a path that puts a new context. You can actually take a context that has a deadline and make a tighter deadline, right? So you can say, actually, you only have 3 seconds from now. So half the time it has a 3-second deadline. The other time it goes to some other code path that has a 5-second deadline, right? It's gone to 2 code paths. There are now 3 possible reasons your HTTP request could fail. Because the top timeout happened, code path A happened, or B happened. All of them, prior to Go 120, would just tell you, context deadline exceeded. And so, unless you did a lot of work to deal with errors, there was no way to customize that error to tell people, hey, you timed out because the whole request took too long, or code path A took too long, or code path B. So that cause literally just allows you to customize that error message, right? Like, it seems really, really minor, but it has this huge impact on debuggability of timeouts.
Which I had at my last 2 months working on stuff because I saw context canceled everywhere.
Yep.
And it was just like, okay, total request went out of time. That doesn't really help me. Like, is it because the database took too long? Is it because, there's a lot of reasons that could be. So what we ended up doing, just real world example, what we ended up doing was deploying logging to see what was actually happening. We had to go through a hotfix process just to start debugging what was going on. So it's an older system, but it would have been nice if it had been built with calls. So that's kind of what that is. And again, this blue in the bottom is how you call it and use it. And then here's some code that it's a little bit more clear. So basically what we're doing is creating that context, and then the parent will cancel, and then we have a way to handle that error. So, and the cancel obviously takes it down as a parameter, and you can handle the issue or the cause if it's something you might expect to be possible. In this case, Voldemort showing up to Hogwarts, which seems to happen to everybody. All right, this one I am not going to lie, I did not fully understand this function. It doesn't seem like rocket science to me, but the use cases were more slim. So you guys are aware, we have covered, I believe, every function in the context library. So we have hit on every single one of them. I wanted to make sure we got the whole library in there, but I'm not going to tell you that I've used this a bunch. I haven't. It was interesting. So this context after func seems like a way to be able to schedule like another way to, so basically what it does is it says like if the process has run longer than it should, let me make sure I get this right. Schedule an alert after 10 seconds, but only if context is still active. This runs only if the 10 seconds pass without context. Yeah, help me out here, Kevin.
The function that's called only if the entire duration passes without the context being canceled some other reason.
Yeah, it's like set timeout in JavaScript, but cancelable. Because you can cancel the context.
Okay, that makes a lot of sense. In 10 seconds, do this unless someone cancels.
Exactly.
Yeah, that's right. Which would be useful again for, and I asked, I was kind of like, well, what are the use cases for this? Why would I want to do this? Just kind of Googling around. A lot of it was logging. A lot of it was, we want to know that happened. We want to be able to keep track of that happening. Maybe we alert on that happening. But a lot of it is for the engineer to get feedback back about what happened and why that process went longer than was expected.
Like, if you start of an HTTP handler, you could say, if this, after 10 seconds, if this handler's still running, call this function that emits a log.
Yeah.
Right? If it's been canceled because the client disconnected and context got canceled by the server, then that function never runs, and you don't get the log saying, hey, this thing took more than 10 seconds.
Yeah.
That's really useful, actually.
So that's context after func, and I believe, oh yeah, this is the example right here. Like, font is all the same color, but you can kind of see timer is being set, and then we call, looks like we call it in there. So that's that. All right, so this is, I think this is my last slide, yep. So if you guys want to grab the code or clone it, that's fine. It's just something I wrote up to kind of demonstrate what's going on with some of this, but it's at my GitHub handle, llama of this demo. I'm gonna jump out of this and jump into VS Code. And walk through the code together. All right. So basically we'll start at main first. So we're just starting up, we're basically gonna run two processes, two workers. The first one is called Leaky Cauldron, and it's the one that's gonna be the leaky go routine for us. And then the second one is Hogwarts. Hogwarts is the safe, the one that actually handles things correctly and functions correctly. So we'll see that kind of in print statements as we do this. But we'll use with cause, we'll use with cancel cause here. And then our cause, if you're looking for it in the logs, you'll see Voldemort. There's like anything that's related to the cause. But basically what we do is we send over our two processes, and then we give them a time to just print out some logs that they'll do, saying, you know, I'm working, in this case just printing and sleeping. And then we'll actually call right here, we're gonna use our cause, we're gonna create something, a cause, we're gonna cancel manually, just like call it. And then give our processes some time to clean up and then shut down. So I'm just gonna run this code for us. I'm just gonna spit out a bunch of different things here. Let's see my terminal.
Boost that font size just a little bit.
We don't know how to do it. We
Can-
don't have the technical.
VS Code
No,
plus, it's easy.
Command
Much better.
plus is not an option.
Yeah, beautiful.
I don't have all this leak like. There we go. So this is the leaky routine. Leaky cauldron doing work, and it's just going to keep going. Be annoying, and choose the resources, and this is where we actually handle context.done. And this is past the context, as you can see right here in 24, and then right here we have. As we call Hogwarts, we're going to pass it a context that was created with a cause. So let's run it and see what happens. This. Okay, so this is the program starting up. And they do some work, both of them side by side, as we're seeing in this section here. And calling cause, Voldemort is here, all tasks have stopped. And then that actually happens, this is it. So this is the actual cause coming back from the context right there. And then Leaky Cauldron didn't care and is still just considered resources. So, all right guys, and that's what I've got for you today. I'm open to questions and other comments. We'll wrap up. Questions? Comments? Yeah.
Can I make one comment? If you go back to the slide where you showed the example of calling each of like ways to create a context.
Super. This one?
Yeah. Always remember to call cancel. It leaks if you don't. That's all.
That's a very good.
Oh, yeah. I actually was sitting here right before I started, and I was like, I didn't put it in there.
For like defer cancel?
That counts.
Just to make sure that it always cancels. You can call cancel multiple times and it's fine. So.
I do it in my code, so we'll at least demonstrate it there. Right there.
Oh, perfect.
Yes.
Yeah, that's great.
Anything else?
No, I think, I don't want to make you type it so hard, but I do think there's some stuff that we said we'd cover around the values and how that works.
Yeah.
The key type, so, I don't want to step on your toes. I think that was awesome.
I don't feel like my toes are stepped on. I prepared this while I was sick with a cold, so I could squeeze everything I wanted to.
No, that's great. So I will take over and I think we'll just poke at some fun stuff for context if, we'll just say that. We can all bring that chat instead. I want to make sure everyone.
Break.
Who said that? It wasn't Todd. I heard Todd next. No, that was fantastic. I think that's. And there's nothing worse than trying to communicate someone else's typing. So I will not subject you to
Thanks.
type this, type that, like,
I'll just jump right out of the call.
good night.
We'll do that.
Yeah, you should. No, that's really good. That is. I'm just only doing this because I think context is so misunderstood. There's some really, really neat stuff in there. It sounds like we have some other people that are really aware of context. I just want to point out some like interesting technical stuff to make sure everybody has some extra value from that. Give me 1 second, because I'm also pleb and use a mouse.
Well,
So,
like,
plug that in.
you can pass it as actual.
I love the mouse.
Do whatever.
Use it forever, and you can try it from my cold dead
That it
hands.
turns okay,
Okay, I'm actually going to use your code, because I thought that was good code.
but
So
context is way before generic.
let's talk about a few things with context. So I think you covered the context cancellation stuff really, really well. Covered the timeouts, all of that. I really wanted to get to some best practices on context values, and it hits on some of AJ's concepts of like typed keys and what the heck that even means, right? So let's write some, I can actually do some really basic stuff here. Coding, I'm really asking to just, I don't know why I do this to myself. Okay, so we're gonna make our context, right? And I will, speaking of making things actually readable by people, let's make that possible. Really good answer for it. Right, and we saw in the presentation, you can, of course, create a new context. You can wrap, right? We do context dot with value. We slap in our original context, and we add a key and a value, right? And then we can context, or do value equals context value key. Get that back out, right? So everyone's with me so far, that's not complex code, right? All well and good until I pass this context down the line to some other code, right? Some other package, some code base, it's not even mine. And they've also decided to use the string key as the key for their thing, right? And then if I were to then pass this into some deeper function, right, that then wraps that with key, and then something later down tries to get key back out, what's gonna happen is the context, when you ask it for the value, it's gonna basically look through the history of the times the value was set. And like literally every single time value is set in a context, you can't actually hide it. It wraps that and it creates a new context with a new value. So it will look through the history of all the times the value was ever set, find the very first one in the chain, the most recent time someone set a key called key, the string, and return that to you. Right? So if you're passing context through somebody else's library, and then it calls your library, you call something else, there's no safety if you just use these raw strings, because anybody can just set a string called key. Yes?
Are you saying it's FIFO?
It is LIFO. Yeah, the last one. So if I were to do this internally, let's say I wasn't doing this even with the extra complication. If I were to do key and value and then value 2, this, when I print it out, is going to print it out as value 2, right? Yes?
Does it overwrite or replace with a hidden layer?
It actually rewraps. So there's this really, really amazing thing with I deep dove on context. Full disclosure. In the context package, they say, do not make your own context implementation. And at Weave, we have our own context implementation. I stand by that. Come talk to me about that later, and I'll say why I broke the rules. There's really cool stuff that happens. So if we actually go into context with value and like a little bit, context value returns back to you, right? Context is an interface, like error. So anything that implements this handful of functions, and there's what, 1, 2, 3, 1, 2, 3, 4. There's 4 functions on the context interface, right? Anything in Go, any type that implements those can be passed as a context. So when you say with value, what it does is it returns something that implements context, but there's no like hard type. There's just something. And so when you do with value, it actually wraps it in this value context. Value context contains the parent thing, the parent context, and the key and value that you gave it. Notice those are both any, those aren't strings. I'm using strings, but they'll take anything. So if you then take this value context and you use that to another thing with value, it's just gonna say, well, my parent is this other value context, and then when it kind of creates this nested recursive function. Let's see if I can do this really efficiently.
It's essentially a linked list is what it is,
It's
right?
essentially a linked list, right? So you would have something like this. I know this is sort of hard to see. If I do some more new lines, this becomes a little bit easier to hopefully reason about. And no, it doesn't. All right, so we've got a value that has a parent thing that has a key and value, and then another one that has another one. It's like each context links back to the previous one. So when you do this context.value, you can actually go into code, and I encourage you, I think we all take this for granted in Go. I go to Python or I go to Java, and then I'm so angry when I can't go into what the language itself is doing, so do not take this for granted. You can follow the Go code base to figure out what anything you do in Go does. Like, that's magic. Go to Java and try to find out what anything Java does and just get sent to a header file and you have no clue what's executing. If you want to know what context does, you just go in here. And we go down to the, I think it'll be easier to find by going to this with value. We go to the implementation of value context. Not linking into there. Put an extra U in there. Right. Here it is. So value context, when it asks for a value, literally, remember, we have these layers. We have a value context that's got a key value in the parent. So you say, give me the value of this key. The most recent child says, is my key match that key? Okay, here's the value. If not, ask the parent. If that parent doesn't have it, ask the next parent. Like, it literally just follows up the chain till the first time that the key that you're asking for equals the key that one context contains. Yes?
So is it buried, or do you have to, like, if you want to get around that, do you have to, like, reference the parent directly and then ask?
You have to, and you can't get the parent back. There's no way in the context package to actually directly get a parent.
So it's there in memory, but you have to, you can't access it.
You can't get it, yeah, it's there in memory, and it means it's immutable. It's really good, so if you've ever debugged, if you hit a debugger in Go, and you've got a context, and you like actually start to expand the structure of the context variable in your debugger, it's like layers after layers after layers. So, yes?
Can you go to definition on this lowercase value function? It's
Yes.
not just calling like c.context.value.
Yeah, it's down here.
Okay. It just handles the other context types.
Yeah, there are context types that don't even have values. Like when you set a timeout, it wraps the previous context with a timeout with a new context with a timeout. So there's this layer, this immutability layer is how context can be passed around Go routines willy-nilly. There's nothing ever changed. There's only new things added and new layers added. So if you have 2 layers deep and you pass a function off, you spin off a function that knows about the context 2 layers deep, then you add 10 more layers and spin it off to another function, they both play nice at the stack that they're at because they can't change each other. They're only aware of whatever layer of the linked list that they're at. So anyway, getting back to my original point, very, very importantly, the keys are not strings, they're any's. And the any's go down to types, like specific types. So if I were to declare a just string wrapper type of context key, int is actually pretty conventional. And then I were to declare a constant of my key. Here's a really fun Goism if you've never seen this before. This is the super, super conventional Goism. And if you don't know what this is, you can hover over this, it'll tell you what the number is. Iota is literally kind of Goisms for just an index based on the element that it is in that block of constants, right? So if I were to make my key 2, you don't even have to do the iota, I don't think. My key is going to be automatically given index 0, my key 2 is index 1, and then because there's a type any here, if I do this, and let's get this really confusing for people. context key 2. I did miss one piece. I gotta actually tell it it's a context key. Types.
If you want to make those context key 2s.
Thank you. Oh, live coding. One day I'll learn.
It's fun, you should do it on Twitch.
On the second one.
These 2A. Pretend these are different packages and they have the same names. So we'll hover over these in case you don't trust me. Editor, comment next to it says that's 0. This is literally all just, this constant is just a type constant of context. The type is context key and the value is 0, right?
You don't put the other iotas, it's just one iota.
I'm just gonna put them in there for explicitness.
I think it resets it. Does that work?
It works, yeah, you can see it changes from 0. The comment, the editor help.
Oh, okay, all right.
Totally valid. You don't have, it's optional. I'll put it in there for explicitness, right? If this was confusing people, I could literally put 0 in here and 1. It's the same stuff, right? So here's my key. It's just an integer of 0. Here is my key 2A, because naming in the same package, also 0, right? If I were to put both of these together, even though I look over this, this is 0, and I look over this, that's 0 as well, these do not overwrite each other in the thing. So if I were to do this twice, for explicitness sake, I could run this, just have to trust me on this. This one, the first line here, val will be value, and value 2 will be value 2, right? Even though they're both just 0, the actual data for that is 0 both times, because they're stored with their type information associated with them, right? Yes, Brandon?
And just to be clear, if you were to say context value, the integer value 0, that doesn't return any value, right? Because
Yeah.
the type would be.
That's a very good point. These are value 1, 2, 3. Each of these, when you get them back out with their associated key, if you get it back out with the literal 0, you would get value 1. If you get it back out with my key, because it's typed, right? Because under the hood, Go interfaces, that any that we pass is actually a pointer to the type of thing and the data of that thing. You can compare the entire pointer to say, like, you have to be pointing to a 0 of this type. You have to be pointing at a 0 of that type. Yes?
Is this the reflection nonsense that Go does?
Yes.
It makes it very fast, but.
It's the reflection nonsense Go does. Not super useful, but the main reason is this means when I'm working with one package that thinks it has to have a user context key and another package that needs a user context key, there is no way ever, especially really, really conventionally, what you'll write is you will actually, the rules, if you go look at the package, they say, don't even call context with value in code. Write helper functions. Take your package, make it private to your code base, right? Even if other people are going to call it, make the types private and just make a public helper function for set E. And you just take the, S string, right? So you actually use a context. And then you return the same thing. Right, and then you return exact thing. Create this public function. And the user here, instead of calling this, let's pretend we're in a different package entirely, equals set key value. Right, so you'll see this a lot in a lot of third-party packages you go get, where it's like if you need to stick the logging ID into your context, we want to make sure you always, that nothing else, like you can guarantee that no other code in the entire system that isn't have some sort of access to this private type can possibly set that key, right? So this is sort of the stuff you see everywhere that really makes it guaranteed that this context value is never set anywhere else, and there's usually a getter associated with it that kind of wraps the context.value stuff. This all seems very finicky and extra, but it's really, really important when you're dealing with large code bases to be able to point and say, this context could not have been set anywhere but this piece of code, and nothing can override it because nothing else has access to this private typed value. So you don't have to write the helpers. I have seen people, and it's fine for you to just use, in some cases you just make these constants public, and then at least you have that guarantee that this, like, the individual like strings or integers, those key values, if they happen to have the same raw data, because there's that type associated with them, they never squash each other. So very nuanced, but I highly encourage you, the docs that we didn't look at, the context docs, do like walk through and have almost this exact verbatim example explaining, use these helpers, use private constant types for your key values, and you'll guarantee no one else can touch them but your code. I just want to go over because I thought it's really maybe it's just really nitty gritty. It's very fascinating to me, like these ideas, the immutability concept of that stack of all these contexts wrapping the other ones that make them all concurrency safe. Yeah, that's it. Cool. That's all I had to add.
An experiment I'd like to do to test the sensitivity of these microphones. I have the ridiculously stupid Meta glasses, and they have speakers that go directly to my ear. We don't know if they can pick them up, so we're going to test it right now. If everybody just wants to be very quiet for just a moment. Hey Meta, what's an aardvark?